that when you're solving logarithmic equations after our warm-up, we know that we should check for extraneous solutions. So that might be something that you add into your notebook for today. I didn't give you any like that on Thursday. And if you go back to the worksheet, none of those turn out to be extraneous. But what you should always do is if your original equation had logs in it, at the end when you get an answer, you should just plug it in to make sure that it's not the log of a negative or the log of 0. It doesn't mean that you have to do the full-blown check every time, but you just want to make sure it's not an extraneous solution. Okay, so that's something to note. You do not have to check extraneous solutions for exponentials because the domain for an exponential function is all real numbers, so you can put anything you want into the exponent. You'll have no trouble.
Will every negative answer come out?
No, because like you could have, let's say in my equation, it was like the log base 2 of negative x. If I then solve and x is, let's say, negative 5, when I put that in, it's negative 5, which would make it positive 5. So it's not that negative answers cannot be solutions. It's that when you plug them in, you can't take logs of negative numbers.
So if it's a logarithm, the equation you always need to check the shape.
I would say put that on your list of things to do to always check the log. We'll see in today's, like, you can kind of tell when it's going to happen. It usually involves 2 logs in an equation like our warm-up, but it's just a good idea to check it all the time because potentially it could not work. Okay, so I'm going to talk about this one on the left, and then you guys are going to try this one on the right with your Podbeans here in a little bit. So if you can focus on the 6 to the 2x plus 6 equals 36 to the 2x. If you look back on Thursday on that yellow sheet, there are some problems that were like this. I think number 2 was kind of like this. It had a base raised to an exponent equals a base raised to an exponent. But what was nice about those, and we talked about it on Thursday, was they had the same base. So it was sort of that same idea where Brianna said we could sort of cancel the log in the warm-up if they had the same base. If it's exponential, they should really like have the same exponent if they have the same base and they're equal. Well, we don't have the same base. So if they don't have the same base, rewrite one or both. So that they do have the same base. Now you have some choice here, and you're going to get to experience that choice in that next problem that you work out with your pods. In this one, I'd say it's pretty straightforward. Okay, most important thing that you need to know about this rewrite. You're rewriting how it looks. You're not changing what it is. So you are rewriting it as something exponential, but it still needs to be equal to the same value. So obviously we're going to use what base?
36.
6.
What?
We're going to use the smaller base.
6 raised to 2 is 36.
And Lexi's saying 6 squared is 36.
Right.
So you see 36 there, you can rewrite it as 6 squared. And then you're not changing what it is, you're just changing the way it looks.
Okay.
Now, if a lot of people are going to want to square the left and make it 36, right?
Mm-hmm.
But remember, in the golden rule of algebra, if you square the left, you would have to square the right, and we don't want to square both sides because then they're still not equal. So it's not a matter of doing something to both sides, it's a matter of rewriting something so they look the same. So we're actually going to keep this one as 6 to the 2x plus 6, and this one is going to be 6 squared to the 2x. Which, to me, these 2 lines, I always like to check this after I do it, they're exactly the same. The only thing that's different is the way that 36 looks, but it's still 36. Okay, what would you do with your exponents over there on the right? Multiply them, so that 6 to the 2x plus 6 equals 6 to the 4x. And now we can say the exponents must be equal, right? Okay. You can also think like log base 6 of both sides, and then the 6's cancel. But at this point, we would all agree after Thursday that the only way those things are going to be equal is if the exponents are equal. And what do we get? 6 equals 2x. So x equals 3. Now, you can check your answer for accuracy, but we would not have to check this for extraneous solution because this is exponential and we don't have to worry about it. Okay. If I wanted to check it for accuracy, I'd be looking at plugging in 3 on the left. That would be 6 to the 6 plus 6, which is 12. And does that equal 36 to the 6? The answer is yes, so then it checks, right? So I'm just like plugging it back into the original problem. Are we okay with that? Does anybody have any questions about what I did? Okay, can you jot down the second example? And now I'm going to give you and your pod mates some time to talk it over. I will say this. There's more than one way to do it, but we should all come up with the same answer. And I want you to think about it as an algebraic approach, not a guess and check approach. So think about how you can work that equation. So I'll give you some time.
Well, to get a fraction, you would have to flip it. So it would be a negative.
So like this is what I have right now. Like it won't be like this. We're gonna get
Wait. Oh, I know. Did you get
which turns it into
Oh, wait, okay.
no, I'm just like
Oh, I didn't. So then to get
oh
1/3
yeah,
of 3,
it's gonna be 27. You're right. No, because you're not changing how it looks. You're just changing how it looks.
that should be 1/3 then
No, that
negative
is
1, 2, parentheses, and then negative 3.
Yeah, she's right. Because she's not changing.
Oh,
She's not actually changing.
Yeah. The basis has.
Unless you don't want my answer got X equals 2. Yeah.
And then 3 to
Should be negative 2. Yeah. No, you just leave it as it. It's the exponent. You just do that to get the same base. You can cancel it out. Then you mean you could put it back into it.
Yeah.
Why try and try it?
So then.
Okay, remember
Okay.
that? 29.
How'd you get, what you got in right hand?
Usually three X minus six.
So from then you got 6.
What'd you get?
I got
Yeah. Oh wait, no, 27.
six.
Alright, that was really
No,
close.
wait.
27
Multiply X.
raised it. But then you subtract it to should we raise it
So
second?
then, 2/3.
Is equal second. Yeah. My first thing I did. Yeah, I did 27. Raised it a fourth. Then multiplied.
Is it 3 to 6? 3 to the third.
Three
Yeah,
raised
it's like 3 to the raise of the third
Yeah,
power.
I feel like that thing's really good.
So then you
Wait, so you should do this. Okay.
oh, I understand now.
Oh, well, I was.
You'll say, yeah. Yeah.
Okay, I think it sounds like maybe we're getting closer to answers at the groups. So I'm going to see if there's a group who's willing to share with us their first step. Sierra? Okay, so they decided to look at the right side, 27, I'm going to cut you off right there, and change it so that it has the same base as the left. Okay, so you made it have a base of 1/3. And then, so what exponent did you have to give it? -3. Okay, so think about that. If you have 1/3 to -3, what does the negative do? Flips it to make it 3. Then it's 3 to the third, which is 27. Is that the same thing? Yes. And then all of that, so I'm going to do another big set of parentheses, is being raised to the 2x minus 2. Okay. And at that point, you have the same basis, so you can set your exponents equal. Now we'll come in and we'll check in with the other groups if they did theirs differently, but we'll come up with an answer here. -3x equals, if you ever have this situation, you have to distribute to like both terms, so that's what, -6x plus 6. Add the 6, so that's 3x equals 6, so x equals 2. Okay. Now, I'm curious if there were any groups out there that started it differently. Lexi, what'd your group decide?
So we decided that since you said we could rewrite both bases, we just did 3 raised to -1, so that's 1/3. So it's not changing it, it's just rewriting it. So 3 raised to -1, and then on the other side we did 3 raised to 1/3 to get 27. And then we continued to solve. And we ended up with the same thing I got, but different. We had 3x equals 6x minus 6.
But you still get x equals 2. Yeah. So, like, I would say a lot of people, I think that's the way that I would see it because I think about, like, base 3 is the easiest base for me, right? So I like that. And now I'm just like, okay, just raise it to -1, then it's 1/3, then raise it to the 3, and then it's 27. So I can change both sides. But like Lexi said, I didn't change what it was. It was still 1/3, and the right side was still 27, so I'm allowed to make that substitution. Did any groups make a different substitution? Okay, nice job. All right. Again, we didn't have to check for extraneous solutions there because that's exponential, so we only have to do that with logs. Let's do some log equations. I'm going to do the one on the left to start. So that says log base 3 of x plus log base 3 of x minus 6 equals 3. For fun.
Oh, yeah.
Okay. So, any ideas? We're going to solve.
Can we subtract log base 3 so both sides have log base 3?
If we subtract log base 3 from both sides, or either log, it really wouldn't matter, then both sides would have a log base 3, but it wouldn't be quite like our warm-up, where we could then just, like, ignore the logs because of the other number there. That's always going to be trouble for us. Like, that would be 3 plus some log, or minus some log. Brianna, was that your same idea? Move the log? Oh, what was your idea?
I don't.
Oh my gosh, I started talking and she forgot. Sierra? Okay, on the left side you have two logs that are being added. By the properties of logarithms, those can be condensed into multiplication.
Good job, Katie.
So it's one log. Log base 3. I'm going to write out more than maybe I usually do. X times x minus 6 equals 3. That's the property of log, right? And then the x times x minus 6, I could distribute that. So that's log base 3 of x squared minus 6x equals 3. That's properties of logs is what we did on Wednesday last week. And then what would you do at this point? Mickey says write it in an exponential form. There's no way I'm going to be able to solve for x if it's trapped inside that logarithm. So I need to get out of the
It's gonna
logarithm,
cancel. I can
change it into exponential form. Base 3 is 3 to the third equals x squared minus 6x. What's that? Oh. What are we going to do next?
We can simplify
3 to the third is really 27. How do you solve this equation? You can't divide by 6.
Quadratic.
It is a quadratic. What are some options to solving quadratic?
Quadratic or factor.
Quadratic formula or a factor. So of course I'm going to check if this one
Factor.
factors because that would be least amount of work, right? So in order to factor, what must be true? One side has to be equal to 0. So 0 equals x squared minus 6x minus 27.
That's 3 and then third.
Yeah.
9.
Yes, can you think of factors of negative 27 that would add to make negative 6? Negative 9 and 3. So this is 0 equals x minus 9 times x plus 3. Factoring will never ever go away for you. If you're going to Algebra 3, if you're going to Honors Pre-Calculus, you have got to know how to factor. If you do not know how to factor, and that's on your summer packet for Honors, you have got to figure that out over the summer. I'll go on Cool Math, and I'll become a factoring master.
Well, you can do factoring of Cool Math.
Yeah, you can practice factoring on Cool Math. I know, there's things other than games on coolmath.com. It's
I mean,
crazy.
it's literally called Cool Math Games, though. So like,
Yeah.
There's stuff besides the sugar thing.
Yes, there is.
How is that math related? I've always wondered that.
what, Tess?
No, the sugar one where you
It's
like
all
do
about-
the
Distribution.
Okay, let's stay focused. Let's stay focused.
It's all about distribution.
X equals 9 and negative 3 from the factors.
One of
I don't like
those
that.
is
I wanna do
worse
quadratic.
than
But negative 3 won't work because if you go back up to the very top, you gotta be able to do the log base 3 of x and the log base 3 of x minus 6. So only 9 works to give you positives on those. Okay, excellent. So we're gonna cross off negative 3 and call it extraneous. But 9 works. Okay, not too bad, right?
So would we have to put like the extraneous solution on there?
Yes, you should. Like, I want to know that you know it exists. Like, why would you not have it if you're solving by factoring,
Oh yeah.
right? If you checked it here and only wrote 9, I think that's fine. But nowhere should you just get to 9 and not.
Yeah.
I should still somewhere be able to see that you had factored. Okay, any questions on that? Okay, let's do one more. We'll do the one on the other side, but it's very similar. Natural log x plus natural log x minus 3 equals 1. So put it together, right? That'll be the natural log of x squared minus 3x equals 1 if I distribute. Well, now I can have just one log, so I can rewrite it in exponential forms. It's base e, so this is going to be e to the first equals x squared minus 3x. I would just leave E alone. It is 2.718, but I wouldn't round it at this point. Otherwise, you're rounding a lot because it never stops. So then I would just move it to the other side, which is going to bother some people, but it doesn't bother me. Minus E is just minus a number. Are you going to be able to factor that one?
No.
So now we're going to do quadratic
Quadratic
formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
That was pretty full.
I forgot that.
That was good.
I
Yeah.
didn't forget
Okay, that is not the song I learned.
No.
That is the song you learned.
Okay, now I will say this about like your calculator. So now you've got to do a quadratic formula that has an e in it.
Oh man.
But what I would do is I would just kind of simplify this stuff under the radical a little bit, and then I would go straight to my calculator. So this is really x equals 3 plus or minus the square root of
9
9 negative times a negative plus 4e, and then divide by 2. Okay. Now, if you want to try that all in your calculator all at once, because you have plus or minus up in this numerator, you've got a lot of parentheses to deal with. So if you do it in your calculator, you need a parenthesis to start your numerator. Most of you would do 3 plus, and then you would do a square root, which introduces another parenthesis. And then you would type 9 plus 4e, but when you guys do e, you get another parentheses. You would have to do to the 1, and then you would have to close the parenthesis for the exponent. You would have to close the parenthesis for the radical, and you would have to close the parenthesis for the numerator. So you open, 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 close, 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 divide by 2. Now, if you don't like all those parentheses, you can just do the numerator, and then hit enter, and then divide by 2. So can everybody do that and make sure they can get 2 numbers? And then you got to do minus. Try it, plug it in.
Wait, where did you say we have to do a minus sign?
You would have to do it 2 times. There's 2 answers.
Yeah, wait. You're done. Did I get enough
Let
parenthetical
me know if you're
citation?
having trouble finding anything on your calculator. I get 3.729.
What? I got a syntax error.
So then you're going to do a plus,
I didn't put a single parenthesis.
and
Wait,
then a
is that-
square root.
3.1? Is that
Yours has
pi?
math parentheses.
E raised to pi?
No.
No.
9 plus 4e raised to the 1.
And like in our Elvis, you have to go back and
It's like
change
pi
that
on you
to
guys.
second. That.
I really needed to put a square root over that whole thing.
I wish I had that calculator, because that calculator. Wait, so,
3.729.
wait.
What did I do?
I had no idea
You
where-
can't, if you divide by 2 right there, then you're going to need a parenthesis around your numerator. Because it has plus in it, so you would need an extra parentheses. Otherwise, something else is spelled.
Wait, Miss Crawford.
Otherwise, just do your numerator.
I can't get it. I just wonder, like, where. So there's parentheses there.
Oh, then you chose a different, yeah, you don't want that X root, you want the square root.
Oh,
Yeah.
okay.
3.729.
No, 3.7. Oh, there we go. That's
And then if you go back and you change it to a minus, it'll be negative 0.729. Now remember on the little calculator, you can just scroll up and then you can change the plus to a minus. Was anybody else having trouble getting the 3.729? Let me know. You have to divide by 2 now. Anybody else?
3 points. Yeah.
Grace, did yours come out?
Boom.
Okay, Grace is still gonna plug it in. Now, you should get 2 answers with the quadratic formula, but
Only one word.
the second one is extraneous because we had like a natural log x up there. So this guy is extraneous, it's negative, it's not gonna work. But this one does work because you have like an x and an x minus 3, so 3.729 minus 3 is still positive. Okay. Any questions? Okay, last thing real fast. And I don't know if you want to write this down, you can, but I just more of want to like put over, we started on Thursday, we finished today, all the different ways that we can solve equations with exponentials and logs in them. Why? Well, it goes back to the beginning of our chapter when we said all of these things could be modeled by exponentials and logarithms. So if you can create a model, sometimes you might want to solve for the thing that's in the log or the thing that's in the exponent. Here's an example from our financial formulas. The balance of an education fund, I should say fund, after T years can be modeled by B equals 5,000 e to the 0.0525t. What's the initial investment in that education fund? 5,000. What's the percent increase? 5.25%. And because we're using the E, we must be compounding continuously all of the time. Okay. The question is, how long does it take for the initial investment to double? So what do you know if your initial investment is 5,000? You know that the balance has to be 10,000. So you could say the balance is 10,000. That's equal to this stuff over here on the other side. And now we did some like way back in the very beginning when we did graphing, and it was just like guess and check. We just plugged t's in until we found the one that worked. But now we have a real streamlined way to do it. Just solve for t. So divide by 5,000. That gets me 2 equals e to the 0.0525t. Because I have a base e, take the natural log of both sides. So this is the natural log of 2 equals, the natural log on this side is going to cancel out the e, so I'll have 0.0525t, and then divide by 0.0525. And I'll have my number of years. I think this one comes out to be like 13.2 years. No guess and check required. Woo. And I know exactly, 13.2. So that's kind of like the reason behind like why would we ever want to solve like this? Because we're going to model things with these exponentials and logs, so we want to have a way to find the missing thing. Okay, you guys have a homework assignment. It's on your gold sheets. It's the last homework for Chapter 6. You guys have been doing a good job so far. Tomorrow and Thursday are going to be review days. I think tomorrow will be mainly a work day, and we'll do some kind of review activity on Thursday. Just because, like, coming back from Easter break, we kind of need to, like, get our feet back on the ground. And then Friday's going to be your test.